Hi, welcome to this recording. We were going to discuss quiz 5 review on chapter 3, sections 3.1 and 3.2. So the first thing you want to make sure you understand is to define the difference between what is a statement versus what is not a statement. So statements don't have to be true. So for example, 1 plus 1 is equal to 3. This is a statement. This is not true, but it's still a statement. Okay. Versus a non-statement is having things for granted. So let's say my favorite band will win the Grammys. I mean, we're not sure about this, right? So this is not a statement. And there's many other examples of statements versus not a statement. So please make sure that you look over the notes and make sure you understand how to define whether something is a statement versus not a statement. Another thing that we want to decide is when we have a compound statement versus not a compound. So for example, the compound statement is united by an and, an or a not. So some examples of a compound statement is, so let's say 2 is an even number and a prime number. So we know that 2 is an even and a prime. So this is a compound statement that it's united by an and. So 2 is an even number and 2 is a prime. Okay. However, not compound would be let's say another example of something that's not compound is uh, the billboard says not for sale. So this, for example, it contains a not, but it says the billboard says not for sale. So this doesn't necessarily mean this is a compound statement. Not just because it says not doesn't mean it's compound. Okay, you have to make sure you understand the difference. Okay. What do we mean when we negate a negation of a statement? So if I give you an example of how to negate, all dogs are friendly. The negation of all is, so the negation will be not all dogs are friendly. That would be the negation. Another example of negation. Everyone likes ice cream, or everyone likes chocolate ice cream. what would be the negation of the statement? So the negation, you're negating the first. We say some people do not like chocolate ice cream. That would be the negation. There's also the negation of inequalities. So example, if I give you x is less than 25, the negation would be x is greater than or equal to 25. That would be the negation. So you're just not flipping the inequality, you're adding that equal to. So this is the negation. So you just flip it and add the equal to. Now we want to convert the symbolic compound to words, given that P represents, his name is Jeremy, and Q represents he plays volleyball. So this means, remember that this symbol means and, this symbol means or. So the statement will say, his name is Jeremy, and he plays volleyball. Versus the next one is an or, so his name is Jeremy, or he plays well. Okay. So that's what we have. Okay, but you're writing this down. Number 5. Let's go ahead and talk about this. Remember, this really is negation. So this symbol is negation. So make sure you're writing down the symbols. Very important for this chapter. So we always work inside out. So the inside is, we have a negation. We're negating P. So Jessica does not play the piano. And or Karen plays guitar. And then we're going to negate it. Negate the whole statement. So Jessica plays piano. And so we're negating the or. Karen does not play the piano. No, does not play guitar. So we're negating the whole thing. So we always work from inside out first. So then we could say it is not the case that Jessica plays the piano and Karen does not play the guitar. Okay. Now for the next one. He stays the same. So Jessica plays the piano. And Karen does not play guitar. That should be your statement. So then let's go over the next one. True or false? Some integers are whole numbers. So first of all, what are integers? So remember, we have our whole numbers and then we have our integers. So some integers are whole numbers. So some integers, this is true. Not all. I'm not saying all integers. I'm saying some. So some integers would be 1, 2, 3, 4, so on and so forth. But there's also -1, -2, but those are not whole numbers, but I just said some. That keyword is some. If I would say all integers are whole numbers, that would be false because negatives are not whole numbers. So what about this one? All rationals are integers. Well, rationals, all rationals, so I would be talking about -1, -2, -1/2, are integers. Well, remember, integers do not contain fractions. So this is false. So this is false. Not all rationals are integers. All integers are rationals, yes, but not vice versa. So you got to be very, very careful. Make sure you understand what is rational, what is integer, what is a whole number, what is irrational, and what is real. Number 8, let P represent a false statement and Q represent a true statement. Find the truth value of, so here we have P or not Q. So we know that Q is false or not Q. So we need to negate the true. So F or F, let's see. So F or F gives us F. So we will end up with a false statement. Make sure you know how to create a truth table. Remember when we have two variables, P and Q, true, true, false, false, true, false, true, false, P or Q, true, 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 false, it's a true, false, true, oh, sorry, yeah, false, true is a true. When you get two false in an or, that's when you get a false statement. Going down, we're still going to use the same truth table as above. Let P be now true and Q be false. So we first need to stay with the negation on the outside. So we're negating P. So P is no longer true, so that would be false. And Q would be false, but we're also have a negation with little squiggly. So this would be true. Now we have to do a truth table where we have an and on the inside. So whenever we do a truth table with an and, so we have a P and a Q, P and Q, this is always true, true, false, false, true, false, true, false. True, true, it's true. True, false, 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 false. You have to know how to do a truth table. So if we have a false and a true, a false and a true, we're going to get a false. So this is a false. But then we're negating it. So it's going to be a true. So we always work from inside outside. So very carefully make sure you know how to do your truth tables. Question number 10, let P be true. And so this one is different. So we have P be true. So then we're going to negate it. And Q and R be false. So then this is not true. So this is not true or false. And then and not false, right? So if it's not true, then we have a false statement or a false. And then we have an and true, right? So false or false. So we go back up top, false or false, we get a false. So from here, we get F and T. So false and true, we're going to go back. False and true, we get false. And so our answer will be false at the end of the day. Okay. Working from inside out. Alrighty, let's work with question 11. Find the number of rows. Right now, they're not asking us to do a truth table. They're only asking us for the rows. So how to find the rows, it's determined. So to find the number of rows, you count the variables.